Delighted that our next speaker is Greg Lavers, an excellent scholar and a friend. He's coming from Concordia, and his talk tonight is titled Russell, Gödel, and Mathematical Platonism. Professor Lavers, please take it away.
Okay, yeah, thanks for organizing this, and sorry for those people whose talk I missed this morning when it was three in the morning here. Apparently some people were able to make all of them, but I was not. So I want to talk today about Gödel and Russell on mathematical Platonism. And so I'll start just by talking about some of the interactions between Gödel and Russell. The main, at least intended interaction between Gödel and Russell was this piece that Gödel wrote for the Schilp volume on Russell, the Library of Living Philosophers volume on Russell. Gödel contributed a piece to that, but he was late. He didn't meet the deadlines, and Russell had already answered all of the critics before he received Gödel's. And Gödel's was the most technical, and Russell responded that given that it had been so long that since he'd done any serious work in mathematical logic, he was not in 1944 in position to write a detailed response on Gödel's criticisms. They also met at least once. This is a quote from Russell's autobiography, that he'd met with, he talks about meetings, plural, with Kreisel, Gödel, and Einstein. And he mentions a few things that, well, they were all Jews and exiles and cosmopolitans, at least in principle, but they had this German bias towards metaphysics. So they could never really get very far in finding common ground. And Gödel in particular turned out to be an unadulterated Platonist, believed that there was a knot that laid up in heaven that a virtuous logician might dream to meet one day. So this passage was actually pointed out to Gödel, and he began drafting a response that was among his papers, but never completed. He says a number of things. First of all, he says, well, I'm not Jewish, not that it matters, but I'm not. Second point, he says that he only recalled one meeting between the four of them. And the third point, well, on the question of unadulterated Platonism, he doesn't think his position is any stronger than Russell's in 1921, when he says logic is concerned with the real world just as much as zoology, though only with its more abstract and general features. Now, that quote is not actually in there, but there was a comment of something, he just made a mark where he was going to insert a quotation, and then he wrote something about animals and crossed it out. So that's why people think that's the quote he intended, since he also quotes it in his actual paper on Russell earlier. Now, so here's what I'll be going through today. I want to start by talking about Russell on mathematical Platonism, and then look at what Gödel says about Russell, and then I want to look at Gödel's Platonism, which can be divided into two phases. The first phase, which holds up until about 1959, he thinks that the primary task is ruling out alternatives, ruling out formalistic syntactic views of mathematics, and showing that one of the things he wants to show is that these views actually, if you look at them, assume a Platonistic understanding of number nonetheless. Just one second. Sorry, it sounded like someone was knocking on my office door, but I'm not sure what that was. Okay. So one of the things Gödel wants to show is that other views that seem formalistic, syntactic, tend to assume an intuition, a kind of mathematical intuition. And then I want to talk briefly about the second phase of his Platonism, where he turned to Husserl's position. He especially liked this paper of Husserl's from 1909. And we'll look at some of the remarks there. And I want to say about how both of these positions in Gödel then relate to Gödel, to Russell as well. I think the first one is there's some clearly Russellian-inspired elements in the first phase. The second phase is more in tension with any kind of Russellian view on the status of mathematics and metaphysics more generally. Okay, so section 1, Russell and mathematical Platonism. So Russell describes himself as early on when he broke from the Hegelians, he began accepting a Platonistic understanding of arithmetic, at least. So he says that when he rejected this theory of internal relations, that's the view that any relation between two things, any statement of a relation is really ultimately has to be grounded in a categorical property of just one of the things involved. Once he rejected that idea, he said he came to believe everything the Hegelians disbelieved, and in particular, he imagined all of the natural numbers existing in a row in a Platonic heaven. Here's a quote from the preface to the second edition of Philosophy of Principles of Mathematics. At the time when I wrote Principles, I shared with Frege the belief in the Platonic reality of numbers. And he says that he later abandoned this view with regret. And so now I want to look at some of the reasons why he abandoned his earlier Platonism with respect to at least the natural numbers. In his work, My Philosophical Development, he mentioned that one of the things that led him to move away from a Platonistic understanding of mathematics was actually the First World War. That he was happy to live in the abstract realm of Platonic entities, but the war brought him down to earth in a way he found unavoidable. But there are also more philosophical reasons for why he abandoned his Platonism. The main one being that he came to see Platonism as unnecessary. That he mentions the famous Kronecker quote that God created the natural numbers and mathematicians created the rest. But then he says that it became evident that it was not necessary to even believe in the natural numbers. given his no class theory, we can define if numbers are sets and sets are logical fictions. If numbers are sets or classes and classes are logical fictions, then numbers are logical fictions as well. So here we see Russell saying one of the principal goals of an analysis is to diminish your ontological assumptions. And we can ask ourselves what the smallest vocabulary is, which will enable us to assert what we actually believe to be true. And here is a quote from the Philosophy of Logical Atomism of 1918. And here he's talking about false propositions. So he thinks that there are facts. So if I assert something true, like today is Friday, there's a fact of the matter that makes that true. But if I assert something false, such as today is Wednesday, or Socrates loved aerosol cheese, I'm saying something that he thinks that there's nothing in the world that makes that false. There are not false propositions as well as facts. They're just facts. Something's true if it's a fact, and if it's not, if there's not a fact, then it's not true. We don't have to assume that there are false propositions. And he says that he doesn't think that anyone with a vivid sense for what's real could hold such a view. And he thinks that it's an important property of a good logician to have a vivid sense for what's real. He also, in the Philosophy of Logical Atomism, holds the view that, he discusses Occam's razor as a motivation for a lot of what he's doing there. And he sees Occam's razor as encouraging us to accept theories that are more likely true. Because so long as we don't deny the existence of what we can eliminate from our theories, if we're able to remain agnostic on whether they exist or not, our theory is more likely true than if we say it does exist or if we say that it doesn't exist. Now, in comparison to later views in the early 20th century, it will become common to say, well, to question even the meaningfulness of the claim that numbers exist in a Platonic heaven, or there is a universal naught that exists in the Platonic heaven that virtuous logicians might hope to meet. Russell doesn't seem to show that he's concerned that there is a meaningful question there. He thinks that questions of what exists are important philosophical questions, and that the best attitude is to remain agnostic towards them. Okay, so section 2, I'm going to talk a little bit about Gödel on Russell. This is mostly from Gödel's piece that he wrote for the Schilp volume that was published in 1944 on Russell, the Library of Living Philosophers. Of course, Russell didn't actually write a response to the piece, as I mentioned. He merely inserted a short note saying that he didn't have time or energy to work through Gödel's arguments. And here we see Russell, so we see Gödel agreeing with Russell that he finds it surprising and refreshing to see the realistic attitude in Russell's work. And he quotes here this quote that he likes from Russell, that logic is concerned with the real world just as truly as zoology, though with its more abstract and general features. And he points out, as we saw correctly, that this attitude decreased with time. And he says that it was usually stronger in theory than in practice, because when he sat down to give an analysis of something, the things that he began analyzing often turned out in Gödel's assessment to end up being logical fictions. And we saw that that is in particular true with the natural numbers, say, and classes in general. They're eliminated as logical fictions via the no class theory. And one of the things that that Gödel thinks about Russell is that having retained a more realistic attitude would have helped him. That if we were realists about what he calls classes and concepts, so concepts are the properties and relations of things that exist independently of our definitions and constructions. What we'll see in just a moment, but I'll mention it now, we see that Gödel thinks that somehow we're able to reason with concepts and arrive at knowledge that's true, that's subjectively true about a domain of objects. He sees that as one of the fundamental problems of philosophy. But he thinks that having this realistic attitude would have been helpful for Russell, because he could show, on Gödel's view, that most of the axioms of Principia Mathematica were analytic. And in this paper of Gödel from 1944, Gödel just distinguishes between two senses of analytic. There's the formalistic one, that we can formally reduce something to an identity. That's one thing we could mean by analytic. But there's this other sense of analytic owing to the meaning of the concepts occurring in it. And it's the second one that Russell thinks is important, that we can show certain of the axioms are true on a realistic understanding of classes and concepts, or in this case, classes. And he also is impressed by Russell's idea of the epistemology of mathematics, and Russell's likening it to the other sciences. This is a quote from Russell's logical atomism, that in general, what we take to be a fundamental truth is not always the most obvious one. And we believe the fundamental ones because we believe their consequences. And we disbelieve them because we think their consequences are false. And he says this is the same as it is in the empirical sciences. So here's a quote from Gödel. He compares the axioms of logic and mathematics with the laws of nature. Oh, sorry. My quotes are being blocked by this window, so let me just, okay, sorry. So that the axioms need not be evident in themselves, but rather their justification lies exactly as in physics in the fact that they make it possible for these sense perceptions to be deduced, which of course would not exclude that they are also have some kind of intrinsic plausibility similar to that in physics. Gödel also says that the axioms, the paradoxes of set theory are no real worry for a Platonist about mathematics, that it only shows that our intuitions are not infallible, but our senses are not infallible either. Our senses can deceive us, and a mathematical Platonist, need not be any more concerned about the paradoxes of set theory than an empiricist is about being misled in some instances by our senses. Okay, so I want to talk a little bit now about Gödel's and what I call the first phase of his Platonistic view, where he is mostly a lot of his energies from 1953 to 1959 were directed at writing this his third contribution to the Library of Living Philosophers. He contributed on Russell, on Einstein, and finally he was writing a paper reacting to Carnap's philosophy of mathematics for the Library of Living Philosophies, for his volume on Carnap. In this case, he never actually submitted it. He thought that he never had a draft he was completely satisfied with, but there were 6 remaining drafts in his Nachlass. And so when he says that when he finally writes to Schlick saying that he doesn't intend to actually publish the article, it's already very late at this point. He wants to say that one of the reasons is that what he's dealing with in the paper is what he sees as one of the basic questions of philosophy. That's what I alluded to before. How do we begin by reasoning about concepts and arrive at knowledge of an objective reality involving objects? He doesn't have an answer to that. He doesn't have a complete answer, but his strategy is to show that the opponents, those people who do take a more formalistic, syntacticist attitude towards mathematics, are also helping themselves to a mathematical intuition when they're constructing their systems. Here's a footnote from the paper on Carnap. The existence as a psychological fact of an intuition concerning the axioms of classical mathematics can hardly be doubted. We don't know exactly how it works. That's one of the major problems. That is perhaps the most important philosophical problem for Gödel at the time. But we all know we have the ability to understand non-finitary mathematics. We have this mathematical intuition, and it can hardly be psychologically doubted. This is from a short quote from Wang's book, A Logical Journey, where he talks about conversations with Gödel. And Gödel said of his interactions, he talks about his interactions with the Vienna Circle, that he says in another place as well that the Vienna Circle, he's thankful to the Vienna Circle for showing him all of the important philosophical problems. He says that their solutions were of no value, but they knew what all the important philosophical problems were. And he says that in his own work, having his realistic attitude allowed him to do things that he wouldn't have been able to do. Some of his early results in logic would not have been possible if he had the more common, at the time, more finitary inclinations, to reject non-finitary reasoning out of hand. Now, so I want to begin talking about the article on Carnap by talking about earlier, when Carnap was writing the logical syntax of language, the German version came out in 1934. Sorry. Gödel had read a draft of it, and the correspondence between Gödel and Carnap is centered around this point that Gödel realizes that Carnap is trying to define mathematical truth for what he calls his language 2, which is a higher order language. It quantifies not only over objects, but over properties and so on. And when Carnap introduces quantification, which is essentially quantification over subsets of the natural numbers, Carnap intends to understand that quantification substitutionally. That is, he plans to say that it's true so long as for every definable predicate it holds. And Gödel writes to Carnap saying, well, sorry, that's going to lead to problems, because something might be true of every definable predicate, but not true of every predicate whatsoever. And so you're going to have false mathematical statements come out as analytic. And Carnap accepts Gödel's argument, references him in the work, and says, as Gödel showed, we have to do it this way. But Carnap still calls his definition formalistic and formalistic or syntactical, even though he's presupposing a standard interpretation of these uncountable domains of objects or entities of some kind, right? Subsets of the natural numbers. He's assuming a standard interpretation of that, but he's still claiming it's formalistic or what he calls syntactical. At the time, he used those interchangeably. But Gödel wants to say that in his article for the Schilp volume, Gödel wants to say that that is illegitimate on Carnap's part. You can't just define. It's misleading to say all mathematics is nothing but the syntax of language if you define syntax broadly enough to include all of mathematics. That's what he sees Carnap as having done. And so one of the things that one of the main points about Carnap is that he makes misleading claims by defining things in a certain way. And if you define syntactical in a more traditional way, you find out that not much of not all of mathematics, at least, is syntactical. Now, there's a lot made of this argument in this paper based on the second incompleteness theorem. So the the argument goes that, well, we use mathematics in our sciences, and we have no reason for knowing if we don't help ourselves to mathematical intuition and say, oh, well, the piano axioms are clearly true because they're true in the domain of natural numbers. He thinks that route is blocked from the syntactical philosopher. And so what is left? Well, we can't give an epistemically satisfying proof of mathematical proof of consistency. So the only thing left is just to hold them as hypotheses, that we just accept them. We don't have any reason for thinking they're consistent. We accept them, and we make predictions. And so the syntacticist might say, well, look, I'm going to stick to my guns and say, look, they're just stipulations we accept. And if they're consistent, they have no content. And so mathematics is either wrong, right? It will either lead me to say contentful things, or it is consistent and it's as I'm saying it is, because it's compatible with all experiences. If it's consistent, it won't lead us to assert false empirical claims. Right? If it were inconsistent, everything would follow. And Gödel wants to say that on a reasonable interpretation of what an empirical claim is, it will entail false empirical claims. And here, at exactly this point, which I think is a crucial point in his argument, he's saying that, okay, even if you're going to dig your heels in and say, look, either mathematics is just wrong, it's inconsistent, and will lead me to say false things, or it's exactly as I say it is. They're just stipulations with no content. And there, it's here where I think the connection to Russell becomes clear, because he's saying that in that case, then the epistemology is very much like Russell thought it was. The mathematical axioms that you call stipulations, well, that's just arbitrary, because it's only ever mathematics and physics that's tested against experience. We can't test them each independently. And so to place all of the content on the physical laws and none on the mathematical laws is arbitrary and unmotivated. But what it shows, he thinks, is that mathematical propositions are very much like physical propositions, and the epistemology here is very much like that's suggested in the quote he likes from Russell, that we accept mathematical and physical laws because we think that they lead us because what follows from them are things we believe are true. And here's just another quote. By success within pure mathematics of some non-evident mathematical axioms, I mean that many of its consequences can be verified on the basis of evident axioms. The proofs, however, being more difficult, and that, moreover, it solves important important problems not solvable without it. This is from is mathematical syntax of language. Is mathematics syntax of language, the paper that he wrote for the Schoep volume on Carnap. Okay. Yeah, so this is from the Gibbs lecture. I mentioned this before, that he takes it that our knowledge in mathematics is not any more ruled out by the axioms, by the paradoxes of set theory. It's actually no different than our belief in empiricism is shaken by a straight rod looking bent when it's immersed in water. Okay, so now for the last part of my talk, which is going to be quite short, I want to talk about Gödel and Platonism. So in the last part, I think Gödel's position is very influenced by Russell. It can even be called Russellian. Russell ultimately thought it wasn't important, that it was better to reject Platonism because it was unnecessary, and not because he thought it was absurd. It wasn't a meaningful question. No, it was just unnecessary in Russell's view. But Gödel thought that it was very much in keeping with how mathematics actually works, even on a syntacticist interpretation. Even Carnap was helping himself to mathematical intuition in writing the logical syntax of language, which Carnap actually admits in his response to Bett in that volume, where E.W. Bett accuses him of helping himself to the standard interpretation of certain concepts in the work. And Carnap says, yes, I think without doing so, the whole project would miss its mark. So let me turn now to this last phase, which I think is, I want to say this phase is very un-Russellian. But so let's look at what's involved here. So here he mentions this. He's largely influenced by this 1909 paper by Edmund Husserl, Philosophy as a Rigorous Science, and comes to believe that therein lies the answer to what I've called previously the fundamental problem of philosophy, or Gödel referred to previously as the fundamental problem of philosophy, that how do we begin by reasoning about concepts and arrive at objective knowledge of objects? And so let's look, and I think it's clear what we can find things in Husserl that are clearly attractive to Gödel, but then I want to say very briefly at the end why it would be unattractive to Russell. So here's a quote from that paper. Every type of object that is to be the object of a rational proposition, of a pre-scientific and then of a scientific cognition, must manifest itself in knowledge, and thus consciousness itself, and must permit being brought to givenness in accordance with the sense of all knowledge. So Gödel sees this as something of a generalization of a Kantian position. So Husserl wants to say that any kind of scientific object must first be presented in consciousness as a phenomena, and not all of phenomena can be understood in terms of the natural world, the world of space-time and causality. And it's absurd to think that you could understand all objects that way. And so Gödel thinks that this provides a way of understanding mathematics as just as objective as natural science, even though its objects do not fit into the world of space-time and causality. And so here he's saying that here's Husserl's talking about the absurdity of trying to understand something that is not an object with causal properties, trying to naturalize a phenomena. So Husserl's science of consciousness, he refers to as phenomenology, and he sees that any science begins with a study of phenomena, the science, it was very successful in naturalizing a lot of things, but it's absurd to try to extend that beyond its domain. And so I said I wanted to talk very briefly about why Russell would completely reject this second stage in Gödel's thought. And that's just that Russell turned away sharply from any kind of Kantian epistemology. So the idea that all objects originate in cognition is something that Russell would just flat out reject. So at this stage, Gödel is accepting this very Kantian philosophy, rejecting any kind of naturalism. But here we see a quote from Gödel showing that he does exactly the opposite. He strongly accepts a naturalistic view of the world and completely rejects any kind of Kantian. He thinks that the Kantian just places far too much importance on the subject, that in reality, subjects only exist in a very small portion of space-time. And throughout most of space-time, there are no subjects at all. So anything subjective is really the exception and not the rule, whereas on Gödel's view, it was exactly the opposite. Everything first presents itself to consciousness, and then can be thought of as the object of any specific science once it's understood, once it's more completely understood. So that is what I wanted to say about Gödel and Russell here today.
Thanks so much to Professor Lavers for a wonderful lecture. Talk, I should say. But much appreciated. And now we move into the Q&A. And I wonder if there are a couple of questions. Apologies to Professor Cargill. I think we're going to run a couple of minutes late. But that said, let's have some questions. And I believe we have a comment from Dr. Bachu. Please go ahead. Or perhaps you were just agreeing to
no.
the slight delay.
Yes. Thank you for your lecture, Professor Lavers. What results from all that you said is actually that Russell's agnosticism is based on a choice, not an argument, isn't it? He simply chose to be an agnostic, and all the rest of philosophers all the rest of idealist philosophers are meaningless for him, isn't it?
Well, it's a choice, but he thinks it's a choice that allows us to be more likely correct. That the agnosticism, he thinks, is the strictly weaker position, and weaker positions are more likely correct than stronger positions. So he thinks that we should.
But when you introduce correct in the discourse, you fall back into the old quarrel of between idealists and realists. So you know. Correctness, as you know from Plato, involves a criterion, the third man. So you need always a criterion to be to assess that something is correct. Whereas the practical agnosticism, I would call it so, the practical agnosticism of Russell doesn't involve such a criterion. Perhaps I'm wrong.
Well, so I think he thinks that there is, when he talks about ontology, he always thinks that there is a meaningful question and it does have an answer. And we are well advised to not take a position on it if we don't know one way or the other. So if we can avoid making a commitment to something, we ought to. So yes, he's supposing against the idealists that these questions do have answers, that there is one of the positions is correct and one is incorrect. If you either assert or deny the existence of some kind of object or entity of some kind, one of those answers is going to be right and one is going to be wrong. That's the position, at least of philosophy of logical atomism, where he talks about Occam's razor. Clearly, there's going to be one position that's right and one wrong on the existence or non-existence of any type of entity. And so the best we can do is not commit ourselves either way.
Thank you so much for the question and answer. Next up, we have a question from Professor Nikolai Milkov. Please go ahead.
Thank you very much for your presentation. I have two questions and one remark. What is the role of Wittgenstein? So Wittgenstein worked together with Bertrand Russell for years, especially in 12, 13, and 18 even. And Wittgenstein, at this point in time, is very well known as a logician and mathematician who maintained that logic is tautological. And mathematics is just a method of logic. So, of course, not Platonism, because as Russell somewhere put that, I was very disappointed when Wittgenstein convinced me that mathematics is a very trivial thing. It is not something sublime. It was a path back from Pythagoras, not from Plato even, but from Pythagoras. So this, what is the role of, you talked something, we taught something about the First World War, but as I see the development, Wittgenstein's role was much more important. The second question is, what was the development in against Plato by Bertrand Russell between 1903 and 1910 in Principia Mathematica? Was he exactly Platonist in the same form as 1903? And my remark is, Russell was also a kind of German philosopher, because, you know, he wrote about Leibniz, he was a new Hegelian. And I remember quite well when he first visited America in 1896-7. He was convinced that German academy is better than the British one in every respect, especially in mathematics. He discovered Kronecker, he discovered Dedekind at this point in time. So, and he was very interested in philosophy, not just in philosophical logic, not just in mathematical logic. So Russell was a type of German scientist or academic because he combined his philosophical studies and mathematical studies with philosophy. It's typically German. It is not Cambridge, but Russell went in this direction. Thank you.
Okay, yeah. So there's quite a bit there. Let me start by Wittgenstein. I didn't want to talk too much about Wittgenstein, but yes. So the philosophy of logical atomism, which I did talk about quite a bit, Russell is it begins by saying most of these ideas come from a student of mine, Ludwig Wittgenstein, who is now off fighting in the war. I haven't seen him since 1914, and I don't even know whether he's alive or dead. And one of the clear influences on of Wittgenstein is in the logical philosophy of logical atomism concerns the logical connectives. That Wittgenstein thought that there were nothing in metaphysics corresponds to the logical connectives. That if I say A and B, that's true because A holds and that B holds, and there's nothing corresponding metaphysically to the connective and so the connectives and even the quantifiers can be understood in terms of the general form of a proposition and so on, with just this operation of joint denial is all we need to build up propositions, but all that needs to be true is a certain set of elementary propositions in order for our propositions to be true or false. So that clearly had an impact on Russell in terms of the connectives. So when he's talking about the not up in heaven, in the Platonic heaven, influenced by Wittgenstein, he doesn't think that there's anything corresponding to that. I didn't really know what to say about Gödel on. Gödel doesn't deny that he believes in a Platonic not, but he doesn't talk much about being a realist about the logical connective. So I don't, but he's certainly a realist about concepts and mathematical objects. So I didn't. So I think there was a profound influence of Wittgenstein on Russell. When it's true that on more than one occasion, I have that one quote, but it seems as if Gödel seems to think that this was a negative influence, that it didn't lead Russell to improvements in Russell's philosophy, but him to abandon positions that Gödel saw as more reasonable. And sorry, there was really a second part of the question that I wanted to get to after discussing Wittgenstein, but what was the general theme? And I can probably remember what I was going to say.
Was Russell in Principia Mathematica exactly thus Platonic in philosophy of mathematics as in philosophy of mathematics? What was the progress in this area in the 7 years between 1903 and 1910?
Well, he comes to accept the no class theory. So yes. We get to, he gets to the position that we can understand classes in terms of propositional functions. And so we don't have to have any idea of classes as objects of their own. And so, so we don't need to be ontologically committed to. So if numbers are certain types of classes and classes are logical fictions, then numbers as well are logical fictions.
Thank you so much for the question and answer. And I'm sure these are issues we will repeatedly come back to. Just very briefly, if I may, I know we're in overtime here. I hate to ask a question about Carnap in a talk about Russell and Gödel, but I was just wondering, do you find that Carnap gave in too easily when Russell objected about substitutional quantification? So if we consider, for instance, continuously infinitary languages, it just doesn't seem as though that is, I mean, perhaps there's more to the objection and that needs delving into, but it just seems a bit hasty.
Well, so first you mentioned Russell, but you meant Gödel.
Right, yes, that's right.
I probably did that 4 or 5 times in my talk without noticing. Yeah, so, well, it is true. I mean, what convinced Carnap was that in the language he set up, the way he set up the semantics for it, certain claims that were true of all definable predicates, but nonetheless false of all predicates, and he sees that, and both Gödel and Carnap think that, well, they're subsets of the natural numbers, and the real numbers are isomorphic, so you can make false statements of analysis if you are talking about all real numbers. If you say all real numbers have this property, and it's not a property all real numbers have, but just the definable ones have the property. I mean, you could even make the claim that all real numbers are definable in this system, right, and that there are, so you would get something clearly false coming out true, and that is why Carnap says, yes, if we want to give an analysis that's the phrase is something like in keeping with classical mathematics, not in keeping with, I forget the exact wording, but something along those lines. We have to quantify not over definable properties, but over all properties whatsoever. So I mean, there might be ways to get around these problems now, but at the time, in the language that Carnap was constructing, Gödel is just right that it would lead to certain false propositions counting as analytic, and that was not something that Carnap wanted.
I see. I was just the question was driven by this old idea in the Aufbau that moving from the material mode to the formal mode is supposed to preserve truths or something of the sort. And so if that turns out to be technically impossible, that would be a severe blow for various neutralist positions, right? Positions that seek to demur from Platonism without necessarily, to remain agnostic without necessarily embarking on other anti-metaphysical projects, right? And it would be, in some sense, surprising, to put it in the mildest terms, if metaphysical issues of such a purport were dictated by such issues. But perhaps the issue rather concerns predicativity rather than substitutional interpretations of quantification. But anyway, thanks so much for your talk. And if you'd like to add anything more, we could go on. I realize we're a bit late. We have a wonderful talk slated up next. Professor Lavers, we're grateful. And please join me in thanking him. And what I suggest is that we resume in 3.5 minutes for Professor Cargill's talk. Does that work? Excellent. And so let's say we start at 5:15 local time. And for those of you on the East Coast, I believe that will be let's see, 17, 11:15. Yeah, thanks.